Let's do something completely different right now. I think it's best to review the process of pharmacokinetics while we've got that information from last chapter fresh in our mind. But the way in which we're going to be doing that is we're going to be taking the main drug we're going to be discussing in this chapter and just to picture each one of those processes that the body is going to be doing to the drug. So the absorption, distribution, metabolism, and excretion. So the point of this lesson is not to memorize anything, but rather to picture each one of the processes and to understand the terms we're using so we can apply that information to any of our other medications. So let's go for it. When a person is orally administered an omeprazole, the medication goes down the esophagus and into the stomach. Proton pump inhibitors like omeprazole are enteric coated. And the enteric coating is a coating that we put on medications to make sure that they dissolve in the small intestine rather than the stomach. That type of coating is put on a medication, mostly if that medication is destroyed in the stomach acids or if it's an irritant to the stomach. Let's go back up to the stomach right now because I'd like to make a note on something else. Omeprazole and other proton pump inhibitors work on a specific enzyme found in a specific type of cell, the parietal cell that's in the stomach. Recall the appearance of the stomach wall. If you zoomed into the stomach wall, you'd find that the stomach has gastric pits, and that those pits are composed of several different types of cells. One of the types of cells is the parietal cell, which are depicted right here. Taking an even closer look at the parietal cell, it would look like this. Remember that omeprazole is not going to access the parietal cells from the stomach. It's going to go all the way through the entire process of absorption in the small intestine, metabolism, and distribution before it accesses the parietal cell from the blood vessels and the interstitial spaces that are in this area right here. As omeprazole goes from the stomach to the next structure of the GIT, it'll enter the small intestine where it is absorbed. Normally for omeprazole, it will finish the absorption process in about 3 hours. When the omeprazole is absorbed into the bloodstream from the small intestine, about 95% of it will bind to the proteins. Recall that this protein binding is variable. The medications can have a very high binding to the proteins, and other medications might have a very, very low binding and sometimes no binding to proteins. For omeprazole, it's 95% bound by proteins, which will help carry it through the bloodstream. Then the proteins carry it off toward the liver in the portal venous system. When the millions of tiny little drug particles go through the liver, the unbound omeprazole, the omeprazole that's not bound to the proteins, most of that is going to go into the hepatic cells or the liver cells from the hepatic capillaries into the hepatocytes. And you may be wondering right now, what is it that is so special about the liver? Why is it that all of our medications want to go straight to the liver and go into the liver cells? Well, while most cells can help metabolize medications, the liver cells have full access to hundreds of what we call cytochrome P450 enzymes, which are abbreviated as CYP enzymes. Individual enzymes from that superfamily of enzymes are known as CYP something something something, at least 3 letters and numbers after that CYP. You have to remember that our body thinks of all medications as being toxins. So it wants to metabolize them as quickly as possible. And the liver cells can do this quicker than any cells in the body. The first time the omeprazole goes through the liver into the hepatocyte, or in other words, on the hepatic first pass, one of the hundreds of hepatic cytochrome P450 enzymes will alter that medication slightly. And jumping ahead for a moment, later the already altered medication that has been circulating around will go back to the liver where a phase 2 reaction will make it very water soluble and easily excreted. Ultimately, you're going to hear the word bioavailability quite frequently, so we should know a little bit about what that is. Bioavailability is the fraction, the percentage of the administered dose that enters into systemic circulation unchanged. If we injected the medication into a vein, for instance, or in other words, intravenously administered the omeprazole, the bioavailability would be 100%. 100% of that medication would get into the circulation unchanged. But we took the medication orally. So for omeprazole, the bioavailability is about 60%. And you may be thinking, why does only 60% of the omeprazole get into the circulation unchanged? Well, a bit of the omeprazole is not absorbed, and some of it gets metabolized on the first pass through the liver. But there is also something that occurs to about 20% of it right here at the liver. I'll let you think about what that might be, and we'll come back to that in the Applying Your Knowledge quiz. We don't need to concern ourselves too much about the bioavailability, but we should understand some of the basics, like the fact that if a drug has a very low bioavailability, it may have to be injected or administered in a different way. Or if one proton pump inhibitor had a bioavailability of 30% and omeprazole had a bioavailability of 60%, you can understand that you'd have to take less of the omeprazole in order to get the same effect as the other medication. And once again, you don't have to worry too much about that as long as you understand the basics. Once the omeprazole goes through the liver, it goes off into general circulation, and it will have access to the capillaries, or sometimes called capillaries, near the parietal cells, so that the action of the drug will start to occur. Because the medication is actually getting to those enzymes that it will affect. For omeprazole, the inhibitory effect begins in about an hour after you take the medication, and the maximum effect is seen in about 2 hours after the medication is taken. One important note is that the proton pump inhibitors only work on the acid pumps that are working at the time that the omeprazole is there in the parietal cell. So the way that we have to take the medication, omeprazole needs to be taken on an empty stomach, and then about a half an hour later or an hour later, the person should consume food. And what that does is starts to activate those proton pumps, and as those proton pumps are activated and the drug is there at the same time, then the drug can work on the proton pumps. In the case of omeprazole, as we said before, it only works in the cells that have the enzyme hydrogen potassium ATPase. So that makes it pretty specific to the parietal cells. So it's really good that there's a limited number of cells that will have the enzyme that we're working on. That ensures that this medication doesn't have widespread side effects throughout the body. And because of that, omeprazole has a very good, what we call adverse effect profile, or in other words, it's well tolerated. Just to add a bit more information about what happens right here at the parietal cells, when the molecule of omeprazole passes the capillaries near the parietal cells, most of the free drug is going to go through the capillaries into the interstitial space around the parietal cells, and then it's going to penetrate into the parietal cells where it's going to work inside the parietal cell. Once omeprazole goes through the liver a couple times, it's been degraded to the point that it becomes water soluble, and we excrete it mainly by the kidneys. As a matter of fact, about 80% of the drug will be excreted by the kidneys, and most of the remaining 20% will be excreted in the feces. With respect to the half-life of omeprazole and other proton pump inhibitors, that's about 1.2 to 1.5 hours. And normally that would mean that the drug would have to be taken quite frequently. For instance, if a drug had a half-life of 1.5 hours, you'd expect there to be about 5% remaining after 4.5 half-lives, or about 7 hours after it reaches peak concentrations in the blood. But omeprazole and other proton pump inhibitors only need to be taken on a daily dose. So how could that be possible? I'll let you think about that question as well, and we'll come back to it in the Applying Your Knowledge quiz coming up. For right now, I'd like to congratulate you if you've understood what we've been talking about with respect to the review of pharmacokinetics. Remember that our goal was not to memorize the pharmacokinetics of omeprazole and other proton pump inhibitors. We were just aiming to understand and picture the pharmacokinetics of omeprazole. And with that foundation, you'll be able to add to your knowledge each time you hear about the pharmacokinetics of another medication.